Well, we have our first example in section 4.5, marginality, and we have the cost given by 1/8 quantity Q minus 5 cubed plus 20, and the revenue given by 4Q. And maybe what we'll want to ask first is, what are the fixed costs? So, in order to think about that, we're going to be putting 0 in for Q. And it looks like we'll have 1/8 of 0 minus 5. So we'll have 5 cubed. So negative 125 plus 20. And we'll bang this into the adding machine and see what we get. Negative 125 over 8 plus 20. Looks like we're getting 4.375. I didn't give units or context here, but fixed costs make sense that I'm going to be spending something before I even manufacture anything. So now, let's go for the good one here. Where are the critical points of profit? And we could say that P of Q is equal to the revenue minus the cost. And I could actually get a function here. If I was going to do this, I would want to make sure to put this thing in parentheses. But to remind us that P prime of Q will equal to the marginal revenue minus the marginal cost. And then I set this equal to 0. We're going to have the marginal cost equaling the marginal revenue. And so I kind of want to work in the context of this. So let's take a look. What is the marginal cost? Well, we're taking the derivative, so 3/8 Q minus 5 to the second power, and then the derivative of Q minus 5 is 1 and 20 is 0, and we'll have the marginal revenue, and that's very straightforward. Here we have 4. Where do these equal each other? Well, 3/8 quantity Q minus 5 squared is equal to 4. And what I'll do is I'll multiply and divide. So we'll have quantity Q minus 5 squared is equal to 32 over 3. Let's take the square root. Q minus 5 is equal to plus or minus the square root of 32 thirds. And we'll have Q is equal to 5 plus or minus the square root of 32 thirds. Once again, I am going to get some decimal approximations here. And so 5 plus the square root of 32 thirds gives me a joyous 8.27. And I get 1.73. And let's ask one last question. Where are profits maximized? So in order to think about this, we should probably think about the domain here. And the domain is going to be from some 0 quantity to some infinite quantity, right? I mean, there's no constraint on these problems, and I'm not making negative items. So we should think about the profit and evaluate it at 0. And when I put 0 into the profit, we got, the cost is going to be 4.375, but the revenue is going to be 0. So we're going to have a negative 4.375, which is good because we're certainly not going to maximize anything there. Let's go for P as we go to infinity. So the limit as Q goes to infinity of P of Q. And let's just put down to make sure that this is the limit as Q goes to infinity of R of Q, which is that linear function, minus C of Q, which is this cubic. So who's going to go to infinity faster? Oh, the cubic is going to dominate, and we're going to go to negative infinity. That means if we keep producing items, we will get more and more negative of a profit. So you got to know when to stop. Let's check our two values now. So we have to think about P of 1.73. We're going to have R of 1.73 minus C of 1.73. And we're going to bang that into our calculators in a second. And then finally, we'll have the P of 8.27 is equal to R of 8.27 minus C of 8.27. Now, what I'm planning on doing here is I'm going to enter this into my calculator. And I'm just going to put 4x minus, and I'm going to put a parenthesis because I'm going to subtract this entire quantity. So 1/8 times the quantity, x minus 5 to the third, plus 20. I'm going to end that parenthesis. Oh, the 20's in the wrong spot. There we go. End our parenthesis. I'm going to go second, table settings, so that the calculator is asking me if I need to enter in the values. And then I'll go second table, and I'm going to put 1.73 in. And when I put 1.73, I got negative 8.7 or 8.709. That certainly doesn't look like a max profit value. And let's do again. Let's put 8.27. And I get 8.7093. I don't know why I'm carrying so many decimal places. Usually these outputs are dollars. We would stop at 2. But looks like here is our maximum profit. And we're through with the problem.